Good day, math learners! For this video, we will be talking on the polynomial equations and functions. A polynomial equation is an equation involving polynomial expression. A polynomial equation of any degree in one variable x is an equation that can be written in this form, where a sub n minus 1 down to a sub 0, or shall we say the numerical coefficients of the terms including the constant of the polynomial equation, are real numbers. These are the examples of polynomial equations. X plus 2 is equal to 0 is also known as the linear equation because its degree is considered as 1. We have 3x squared minus x plus 7 equals 0, also known as quadratic equation because its degree is considered as 2. And we have negative 2x cubed minus x squared plus 1 equals 0, also known as cubic equation in which its degree is considered as 3. Please take note, class, that the degree of the polynomial equation is determined by the highest exponent of the variable. For instance, the polynomial equation 5x raised to 6 minus 3x raised to 4 plus 2x squared minus 1 is equal to 0 is on the 6th degree, or the degree is 6 because the highest exponent of the variable is considered as 6. If we have this polynomial equation, negative 7x raised to 5 plus 3x raised to 4 plus 4x cubed minus 2x squared plus x plus 3 is equal to 0 is on the 5th degree, or the degree is 5 because the highest exponent of the variable is considered as 5. A value of the variable which satisfies a polynomial equation is called a root, solution, or zero of the equation. Consider these examples of polynomial equations. In identifying the number of roots is based on the degree of the polynomial. In solving linear equations, we expect to get exactly one root because the degree is on the first degree, or the degree is 1. In solving quadratic equations, we expect to get 2 roots because the degree is on the second degree, or the degree is 2, while the cubic equation, which is on the third degree, or the degree is 3, provides 3 roots. This tells us that the degree of a polynomial plays a role in determining the number of roots we are expecting. The number of roots or zeros is the same number of binomial factors in a given polynomial. In identifying the number of roots of the given polynomial is according to the fundamental theorem of algebra. It states there that polynomial of degree n has at least one root, real or complex, meaning if the degree is 3, then the polynomial equation has at least one root and it has to be real or complex number. The statement leads to a conclusion that a polynomial function, or p of x, of degree n has exactly n roots, real or complex, meaning if the degree is 3, then the polynomial equation has exactly 3 roots and it has to be real or complex numbers. This states that every polynomial equation in one variable of degree n is greater than or equal to 1 has exactly n roots, called the polynomial roots. The theorem was first proven by Carl Friedrich Gauss a German mathematician who is sometimes called the Prince of Mathematics. So let us determine the number of roots of each polynomial equation. For number 1, okay, if we have x raised to 5 minus 7x cubed plus 8x squared plus 6x minus 10 equals 0, what is your answer? Okay, there are 5 roots or zeros because the polynomial is on the 5th degree because its highest exponent is considered as 5. For number 2, if we have 3x raised to 8 minus 9x raised to 7 plus 11x cubed minus 9x squared plus 12 equals 0, what is your answer? There are 8 roots or zeros in this equation because the polynomial is on the 8th degree because of this highest exponent, which is 8. For number 3, if we have the quantity of x minus 8 times the quantity of x plus 6 times the quantity of 2x plus 5 squared equals 0, what is your answer? Yes, we have 4 roots or zeros because the polynomial is on the 4th degree since the equation can be written into this equation. X minus 8 times the quantity of x plus 6 times the quantity of 2x plus 5 times the quantity of 2x plus 5 equals 0, in which 2x plus 5 squared in the given polynomial is being expressed into expanded form. According to the concept of identifying the number of roots in a certain polynomial, that it is the same number of the binomial factors in a given polynomial. So there are 1, 2, 3, 4 in this equation or in this given. So we can say that there are also 4 roots or zeros in this equation. Next, if we have x minus 7 times x squared plus 8 squared equals 0, what is your answer? Okay, we have 5 roots or zeros because the equation can be written into this equation. X minus 7 times the quantity of x squared plus 8 times the quantity of x squared plus 8 equals 0. If we are going to multiply the first term of each factor, we come up x raised to 5 as our product, even if there are 3 binomial factors there. But we have to consider the exponent of each first term in our binomial factor. So that is why we have 5 roots as our answer. So this time we will be talking on the polynomial function. Linear and quadratic function are special types of polynomial function. Cubic function are function of the 3rd degree and quartic function are function of the 4th degree are also classified as under polynomial functions. A polynomial function is defined by p of x is equal to a sub n x raised to n plus a sub n minus 1 x raised to n minus 1 plus a sub n minus 2 x raised to n minus 2 and so on, where a sub n minus 1, a sub n minus 2, or a sub 0, or the coefficients of the terms in a given polynomial function, including the constant, are said to be real numbers in which a sub n is not equal to 0 and n is non-negative integer. From the definition of a polynomial function, the following are implied. Each exponent is a whole number. Denominators contain no variable in x. No variable is under the radical sign. The domain of a polynomial function is the set of real numbers. The range depends on whether n is even or odd and also on the value of the leading coefficient a sub n. A polynomial function written with its terms arranged according to descending powers of x is said to be in standard form. That is all about polynomial function. Let's try to identify the polynomial functions from the given set of expressions. For example, number 1. Is this a polynomial function? Yes, this is a polynomial function. This function can be written as f of x is equal to negative 4x raised to 4 plus 3x squared minus x plus 2. Number 2, is this a polynomial function? This is not a polynomial function because the exponent of the fourth term is considered as negative. And according to the definition of the polynomial function, that each exponent is a whole number, not a negative integer. That makes this function not a polynomial function. How about number 3? Is this a polynomial function? Yes, this is a polynomial function. How about the number 4? Is this a polynomial function? This is not a polynomial function because the first term, including x, is under a radical sign. This connotes fractional exponent. How about number 5? Okay, this is a polynomial function. When you are going to expand this one, it will become 9x raised to 4 plus 12x cubed plus 4x squared. How about number 6? Is this a polynomial function? Okay, this is not a polynomial function because it has a fractional exponent in our variable x in the second term. That makes it not a polynomial function. Let us determine the degree and the number of terms of the given polynomial functions. Number 1. What is the degree of the function? Yes, the function is on the fourth degree, or the degree is 4 because the highest exponent is considered as 4. How many number of terms are there? There are 4 terms in the given function. So we have 1, 2, 3, and 4 as the number of terms in number 1. So for number 2, what is the degree of the function? Yes, the function is on the 5th degree. Why? Because the highest exponent is considered as 5. And how many number of terms are there? Okay, there are 3 number of terms. So we will count 1, 2, 3 as the number of terms in number 2. How about for number 3? Okay, so the degree of the function is considered as 0 because we don't see a variable here that indicates the degree of the function. And how about the number of terms we have? Okay, we have 1 because a constant count as 1 term. How about for number 4? This number 4 needs a computation to identify the degree of the function and its number of terms. In order for us to identify the degree of this given polynomial function and its number of terms, we are going to expand this function using some concepts in algebra. So here is the solution. First is to copy the given. Second, we are going to consider and expand this term, x minus 4 raised to 2, using the concept of the square of the binomial. First is to square the first term, and the answer would be x squared. And then multiply the first term and the second term, then times 2. So x times negative 4, the answer would be negative 4x times 2. That makes it negative 8x. Okay, and square the second term in our binomial, which is negative 4 squared. The answer would be 16. Copy minus the quantity of x plus 1. So we have now our first polynomial and second polynomial, and the process in between of the two polynomials is subtraction. According to the subtraction process, that the second term should be considered, that the sign will be transformed into its opposite. So from positive, it will become negative x. From positive 1, it will become negative 1. So our function will become x squared minus 8x plus 16 minus x minus 1. And then arrange them in descending order. So we have x squared minus 8x minus x plus 16 minus 1. Combine like terms. So negative 8x minus x, that makes it negative 9x. 16 minus 1, that makes it 15. So therefore, our expanded form will be x squared minus 9x plus 15. So the given function k of x expressed in standard form, and it has 3 terms. The degree of the function is on the second degree. So this time we will be dealing with the evaluating a polynomial function. It is an important skill in the succeeding topics, means to find the value of the function at a given value of x. For example, in evaluating the polynomial function, we are asked to find the p of 2 and p of negative 3 if the given polynomial function is p of x is equal to x cubed plus x squared minus 7x minus 3. So here is the solution. First, we are going to copy the given function and then use p of 2 to substitute p of x, meaning we are going to substitute the variable x with 2, and the function becomes p of 2 is equal to 2 raised to 3 plus 2 raised to 2 minus 7 times 2 minus 3. After that, we are going to simplify further. So 2 raised to 3, the answer would be 8. 2 raised to 2, the answer would be 4. 7 times 2, the answer would be 14. And then copy 3. And combine, we have 8 plus 4, the answer would be 12. 12 minus 14, the answer would be negative 2. And negative 2 minus 3, the answer would be negative 5. Therefore, our value is equal to negative 5. So, to get the value of p of negative 3, so first we are going to copy the given function and then use p of negative 3 to substitute p of x, meaning we are going to substitute the variable x with negative 3, and the function becomes p of negative 3 is equal to negative 3 cubed plus negative 3 squared minus 7 times negative 3 minus 3. And then we are going to simplify by getting the result of negative 3 cubed, the answer is negative 27. Negative 3 squared, the answer is 9. Negative 7 times negative 3, the answer would be positive 21. That is why we have plus 21 there. And then copy negative 3. So negative 27 plus 9, that makes it negative 18. And then negative 18 plus 21, that makes it positive 3, and 3 minus 3, that makes it 0. So the value is equal to 0. The evaluating of polynomial function is the same process in identifying the binomial factor of the given polynomial, which is the concept of factor theorem and remainder theorem. So let us have this given polynomial, x raised to 4 minus 4x squared plus 7x minus 24 with the value of c, which is negative 3. So this time, we are going to identify the binomial factor of the given function using the process of evaluating of polynomial function. According to the remainder theorem, that p of x is equal to p of c. Therefore, we will use p of negative 3 to substitute p of x, meaning we are going to substitute the variable x with negative 3. So here is the solution. Make the polynomial equation into polynomial function. So, p of x is equal to x raised to 4 minus 4x squared plus 7x minus 24. Substitute p of x with p of negative 3. So, the function becomes p of negative 3 is equal to negative 3 raised to 4 minus 4 times negative 3 raised to 2 plus 7 times negative 3 minus 24. And negative 3 raised to 4, the answer is 81. Negative 3 raised to 2, that makes it 9. 9 times 4, that makes it 36. So we have 81 minus 36. And then we have 7 times negative 3, that makes it negative 21. And we have 81 minus 36 minus 21, copy minus 24. And simplify them further, and the answer would be 0. Since p of negative 3 is equal to 0, therefore x plus 3 is a factor of the given polynomial function. Hence, negative 3 is a root or 0 of x raised to 4 minus 4x squared plus 7x minus 24 equals 0. So, let us have another example, and the given polynomial is 2x cubed minus 5x squared plus 2x minus 11 equals 0 with a value of c, which is 2. So we are going to identify the binomial factor of the given polynomial equation using the process of evaluating of polynomial function. According to the remainder theorem, that p of x is equal to p of c. Therefore, we will use p of 2 to substitute p of x. So here is the solution. Make the polynomial equation into polynomial function. So, p of x is equal to 2x cubed minus 5x squared plus 2x minus 11. And substitute p of x with p of 2, meaning that we are going to substitute the variable x with 2. So, the function becomes p of 2 is equal to 2 times 2 raised to 3 minus 5 times 2 raised to 2 plus 2 times 2 minus 11. Then simplify the function, and 2 cubed, that makes it 8. 8 times 2, that is 16. Copy minus 2 squared, that is 4. 4 times 5, that is 20. Then copy plus 2 times 2, that is 4. And copy minus 11. And then simplify the function, and p of 2 is equal to negative 11. Since p of 2 is equal to negative 11 and not equal to 0, x minus 2 is not a factor of the polynomial function. Therefore, 2 is not a root or 0 of 2x cubed minus 5x squared plus 2x minus 11 equals 0. Thank you for listening, math learners.